Hello, my name is Corbin Jones, and this is the visualization of my second data set. So this data set is pulled from the DKRZ tutorial, which is cited in my paper. And this data set takes a look at the speeds of ocean currents. So this first visualization that we have here is just to get familiar with the data set. And you can clearly see there are gaps in the longitude and latitude projection where land masses would be. So you can see North America, South America, Africa, Australia, Asia, and Europe, and other land masses as well, blacked out. The nice thing here is we're able to look at different representations and projections of the data. So I can switch it to a spherical representation, and then after applying it, get the globe sense of the ocean currents. So this is solid color, really just to get us familiar with the data set before we move on to the second visualization. So the second visualization is, we'll leave off the glyph for now, is in the spherical form. And then I added a calculator value. And this calculator value is meant to compute the velocity of the ocean currents. So this is calculated by performing the square root of u squared plus v squared. So getting the magnitude of those vectors and then overlaying that in terms of this cool to warm scale here. So you can see the scale of the velocity, and you can see the specific points on the globe where the ocean currents are the fastest. And then, so yeah, that was using the calculator. And then our final representation or visualization is adding the glyph as well. So for that, we'll switch back to the longitude and latitude projection because I think that makes it a little bit easier to see this visualization. And as you can see here, so glyph is a way of showing the directionality and magnitude of the vector. So we have V as our scale array, and that's going to allow us to see the final velocity of all of these ocean currents. And if we zoom in, you can see that all of these are different arrows, and their scale and um, is visualized in terms of, the V value, whether that's positive or negative, and that informs the direction. Unfortunately, with this data set, we don't have an orientation array, which might also point us in the direction of the ocean currents, but we can at least see the scale. So the bigger the arrow, obviously, the faster the current is moving at that location. But just another interesting way to see the arrows here. You can kind of see that the large arrows overtake the red sections, which makes sense. Obviously, the fastest areas will have the largest currents, and then these dark blue areas where the water is relatively still don't really have any arrows. So just another interesting way to visualize that speed. Definitely enjoyed exploring this data set, and thank you.